The talk of today is about the theoretical impact of NDF quality on enteric methane production. It's obvious that ruminants are capable of digestion fiber-rich diets. It's also well known that if the content of fiber increases, that we get more and more methane, relatively. So an obvious question is, how does NDF quality relate to enteric methane production? And that's the question I try to address today. To start with NDF quality and methane, can you see them as separate aspects? Can you treat them independently and just do some calculations? That's the first question you might start with. When you look at NDF quality, of course it's the digestibility of the NDF in the gastrointestinal tract which determines what we call quality. And that happens in the rumen and the large intestine. Mike Allen already told us that. It depends on the whole diet, so it's not just the NDF itself, it depends on the whole diet, the feed intake level, and the remaining fractions in the diet. For methane, almost all methane is produced in the rumen, about 90%. It depends a bit on what you are feeding the animal, and it might shift, but in general it's about 90%. And that yields a lot of fermentation end products, including gases, as hydrogen, methane and carbon dioxide. If you look at methane, it also depends on the whole diet. It's not just one part of the diet, it's the whole diet, of course. And also methane yield depends on the level of feed intake of the animal. So if you look at that, both NDF quality and methane, they depend on the same two aspects. And that makes that when you want to evaluate effects of NDF quality and methane, they are two sides of the same coin. You have to treat them collectively, simultaneously. There are three principal factors that affect methane emission in the ruminant. First of all is dry matter intake, of course. It's the digestibility of the dry matter and the chemical composition. If grass NDF quality improves, dry matter intake might increase as well. If this happens, you get a reduction of methane emission per kilogram of dry matter consumed. You get less methane per kilogram of animal products produced, and also as a percentage of gross energy intake, it drops. If NDS digestibility goes up, you might get more methane because you have a better digestibility. Per kilogram of milk, in this case I'm referring to cows, it will go down. But as a percentage of gross energy intake, it will go up, of course. Better digestibility, same amount of gross energy intake will deliver a higher percentage of gross energy emitting as methane. For the contents, the NDF content, that one will go down, of course, if NDF quality goes up. The soluble carbohydrate content goes down normally, it's what we expect. Protein content will go up drastically, and also fermentation product content will go up. All these contents, they all lead to less methane per kilogram of dry matter consumed, or expressed per kilogram of milk, or expressed as a percentage of gross energy intake. So the overall picture here is that with a higher gross NDF quality, I strongly believe that we get less methane emission. But if you express it, and that's an interesting notion, if you express it as what IPCC does in the tier 2 approach as a percentage of gross energy intake, it might still be equal or even become higher if the effects are quite drastic. So that's important to know, that it's not always, you cannot always sense this lowering of methane emission if you express it as a percentage of gross energy intake. And the final notion I want to make is, if you want to quantify methane, you have to consider all the effects of the chemical fractions and dry matter intake simultaneously. Otherwise you cannot make sense of lots of observation, I think. And with this, I want to end my lecture. Thank you.